Hello guys, I'm your favorite mathematics teacher Swapnil Sir and I'm welcoming you all back to yet another video. Already we have started lecture series based on the SPI different topics from it, okay? And within that we have uploaded plenty of the videos, some of the questions on our channel. So if you're interested to see this video, do check in my playlist. So in my today's video, I'm gonna explain to you all one of the magnificent topic from mathematics, which is the probability. It's not our first lecture. Already I have uploaded plenty of the videos on our channel. So if you're interested to see these videos, do check in my playlist. Okay, in my today's video, I'm going to explain to you all some of the questions from SPI exam. Okay, and first of all, I'll explain to you all what actually meaning of a probability. There are different concept and we go for some of the question solving at the end. So without further ado, let's get dive into our today's lecture. Our today's lecture completely based on the probability. Already I have uploaded plenty of the videos on my channel. So let's get start our today's lecture with a new video with a new topic. Okay. So here in our new video, first of all, I will explain to you all probability and their different concept related to the probability. I do have blank screen here. So what actually mean by the probability? Okay, let me explain the meaning of a probability in a simple words. Okay, we have to find out a probable outcome. Okay, likely probable outcome for any event. Okay, any event with respect to sample space and their favorable outcome. Okay, so we call it as the basically probability. Okay, now let me explain probability with some of the concepts here. Okay. So what actually mean probability it is here, okay? With respect to, we go for some of the different example like tossing of a coin, okay? We consider first example as a tossing of a coin. Next example, we go for the dice. We all are familiar with the dice, okay? Tossing of a dice. What actual outcomes are possible when we toss a single dice, when you toss two dice or when you toss multiple dice, okay? After that dice, we go for the deck set. I know that you all are everyone familiar with the deck set. Most of you have been played with that deck also. Okay, deck set. Okay, actually that deck set we are using here to just identify what are the likely outcomes we possible here. Okay, so let's get start. Our first outcome from the probability, which is the coin. What happen if we toss coin? Okay, let me explain with the coin here. Okay. Okay, we go for the coin. Okay. Yes. What happen if we toss a coin? Okay. Whether we get the tail or we get the head. It is a simple outcome when we toss a single coin. Okay. So there are plenty another way that we can toss a coin. We can toss one coin at a time. We can toss two coin at a time. We can toss three coin or we can toss many more coins at a time. Okay, let me explain what happen if we toss a single coin. Okay, let me explain with the single coin. What happen if I'm gonna toss here a single coin? Okay, after tossing single coin, we have possible chances whether it goes for the head or it goes for the tail. Okay, we have only two outcomes for a single tossing of a coin, whether it goes for head or whether it goes to tail. Okay, now see that we have only two sides, possible sides for our coin, that whether when it is a head or when it is a tail. Okay, so after tossing of a single coin, I have two possible outcome, which is a likely outcome, which is head or tail. Okay, yes. Now next, if I toss two coin at a time, two coin at a time. Okay, just for understanding this concept, you may have to select two coin. You can take two coin at a time, toss them at the same time and find it out what are the probable outcome both are probable outcomes are coming from both of the coin. Okay, so these outcomes coming in the form of order pair. Okay, order pair means the two element at the same time. Okay, so if we toss a two different coin, okay, so we get the both. It is possible as a head. Okay, maybe it is possible both coin can give us a head. Okay, or both coin can give us a tail. Okay, this one is the both can give us a tail. Okay, or maybe we have possible chances that one coin can give us the head, another can be tail. Okay, one head, another can be tail. First tail, another can be head. Okay, first tail, another can be head. Okay, these are the possible outcomes when we toss a 2 coin at a time. Okay, what actually happen if we toss a 3 coin at a time? Okay, 3 coin at a time means we have to count. Let me write 3 coin at a time. Okay, 3 coin at a time. Let me write what we have possible outcomes here. Whether 3 of these are getting head. Okay, another 3 of these are getting tail. Okay, let me write it again. 3 of these head, 3 of these are tail, and so on. There are 9 number of outcomes we have, n to the power 2. Okay, so we are tossing 3 coins. Okay, so we get the 9 number of outcomes. Whether it's come like so, first 3 of these are giving us a head. Another next outcome, it gives us all tail. Next 2 head, 1 tail, 2 head, tail, head. Okay, this kind of the outcomes you will get it from here. Okay, so this is the way that we can find it out, the probable or likely outcome for when we toss a single coin. Okay, what happen if we toss 2 coin at a time? 2 coin at a time. Okay, 2 coin. Let me not about the coin. Already we learn everything about coin. About the we go for about dice. Okay, so I know that you all are already familiar with the dice. Dice means it is like a cubical shape. Okay, like it's a cube shape. All sides are equal in measure and having total number of 6 sides there. Okay, dice having total number of 6 sides, and every single side gives us the 1 dot. Okay, and that means if we go for one side, we get the 1 dot, another side 2 dot, next 3, and similarly all 6 sides are having 6 number of dots. Okay, yes. So what happen if we toss a single die? If we toss a single dice, we get the, at a first outcome, we get the only number. First dot means 1 number. When we toss a dice at a second time, maybe we get the 2 as the second possible outcome. Third, we get the 3, 4, 5, and 6. We have only possible these many chances when we toss single dice. Okay, when we toss single dice, we do have possibility to get the outcomes as a 1, 2, 3, 4, 5, and 6. That's it only. Okay, so when we have possible outcome, a total number of 6 here. Okay, when we toss single dice, what happen if you go for the 2 dice? Now this one is for single dice. Okay, now next, when we toss 2 dice at a time. Okay, when we toss 2 dice. Okay, this one is for single dice, this one is for 2 dice. Okay, what happen if we toss 2 dice at a time? That means when 2 dice are coming together, we get the outcome in the form of order pair. Okay, we get the outcome in the form of order pair. Now by using this, let's find out what are the possible outcomes we have here when we toss 2 dice. Okay, yes, first we can write, we get the 1, 1 as the 2 dice possibility for 2 dice. That is, the first dice can give us 1, second dice can give us 2, 1. Okay, first dice can give us 1, second can give us 2. First dice 1, second 3, first dice 1, second 4, first dice 1, second 5, and first dice gives us 1, second gives us 6. Okay, there are total number of 36 possible outcome when we toss 2 dice. Okay, so now see that I have to explain some of the concept related to these outcomes. Okay, so that we are going to learn in the further part of the probability chapter. Now see that, so I have to explain to you all here that what are the actual sample space, what are the elements in our sample space. Okay, what actually mean by sample space. Okay, sample space, it completely defined as we have to find out the total number of outcome in our given set. Okay, now see that we have total number of outcome 6 here. When we toss single dice, we get the total number of 6 outcomes. Okay, so this one is our complete sample space. Okay, in mathematical language we write this one as the sample space. Okay, similarly we can go for the remaining one here, that we can see at the first outcome we get the 1 1 1 2 1 3 till we at the last outcome we get it here 6 6. Okay, yes, that one it goes from the 6 1. Okay, and till end we get the 6 6. Now we can see that all are the outcomes we have here when we toss two dice. Okay, when we toss two dice, all are the outcome which are coming, we consider it as the sample space. Okay, yeah, this one is the definition of a sample space. Now let me explain next definition, what actually mean by favorable event. Okay, yes, now let me explain favorable event with one short example. Okay, one short example I will explain to you all the favorable event, that I have to select the elements here. Okay, now let me write the favorable event. Favorable event. Okay, let me write the favorable event here. So what actually favorable event means here, we have to select the two faces of a dice, it gives us the same number. Okay, two faces, topmost faces of a dice, it gives us the same number. Now see that most of you all are thinking that sir, if we toss two dice, can't we consider the another side or rounded part of the dice as the considerable part? No, it can be considered. We always find it out what are the topmost faces are there. Okay, what actually the topmost faces. So we have to think it about only the topmost faces of our dice. Okay, yes. So favorable event means we have to let me define one event here, then I will go for the favorable event. Okay, so my favorable one event it is here, that I want the two dice having topmost face are same, both are equal. Okay, I need the topmost faces of a two dice are equal. Okay, so let's find out what are the topmost faces are equal here. 1 comma 1. Okay, 1 comma 1, both are the topmost faces of a two dice are equal. 2 comma 2, 3 comma 3, 4 comma 4, and 5 comma 5. Now see that all the same face of our dice, which is a subset of our given sample space. Okay, so what we have here in actual favorable event, that means we have to find out some of the likely events which based on this total sample space. Okay, this one is considered as the favorable event. Okay, now what I want the probability for that favorable event. So I will define it as the probability of a favorable event as number of favorable event divided by completely sample space. Okay, number of a favorable event divided by completely sample space. Okay, okay, let me write probability of favorable event. Okay, so probability of a favorable event, actually it defined as number of favorable event. Okay, favorable, I'm writing it shortly. So it is a number of a favorable event completely divided by number of element in our sample space. Okay, okay, this is the actually meaning of a probability. Okay, so whether you have to find out the probability for any event, or if you wanted to define any favorable event, okay, so that time we consider the probability of a favorable event as a number of a favorable event divided by number of a sample space. Okay, now what we have next condition here. Now see that we cannot define probability which is as a negative number or bigger than 2 or 3 4 like this. We never heard the probability as a 2.5 or 3 like this. Okay, probability it is not bigger than 2 or not bigger than 1 and not smaller than 0. Okay, So probability of any event which lies between 0 and 1, okay, which lies between 0 and 1. Always remember that probability of any event which lies between 0 and 1, okay. First of all, understand the meaning of a probability and some concept here. Then at the end we go for next part, which is the deck set, okay. We go understand about the deck set, okay, and at the end we go for some examples. Now see that probability of any event which lies between 0 and 1, okay. So when we get probability as a 0, then we consider we have here a failure of our probability, okay. Failure of our probability means the probability is a 0, okay. Okay. Failure of probability E, okay. Failure of a probability E, it define the value 0, and success of a probability E which define, okay, success of E, success of probability E, okay. Success of the probability E which define as the event 1 here, and failure it is the 0, okay. So that are the concepts here. Any probability which lies between 0 and 1 means maybe it comes as a 1 by any number, 1 divided by any number, it has to be other than 0, okay, because if denominator goes to be 0, that number can't be defined, okay. Yes, I'm expecting that you all have understood all this part here, okay. Probability of any event which lies between 0 and 1, okay. So consider that you have given event A, event B, event C and event D. How many events you have? A, B, C and D. You have 4 events. If we add all the probability together, we get the answer 1, okay. That means probability of A plus probability of a B plus probability of a C plus probability of a D, which is equal to, we have 1, okay, as the complete addition for all probabilities, okay. If the probability all are the completely independent, okay. So I'm expecting that you all have understood about the probability, okay. About the dias already I explained, okay. Next part, it's left here with the deck set, okay. Let me explain with the deck set, okay, what actually meaning of deck. Okay, you all have seen deck set. Deck set means it is a set of a card that we play that card, okay, which contain total number of 52 cards, okay. How many cards we do have in a deck set? Which is the 52 cards, okay. We have total number of 52 cards in our deck set. Each cards divided into the 13 sets, okay. 52 cards divided into the 13 number of different cards, okay, which is having heart, spade, diamond and club, okay. Heart, okay, let me write it. Spade, diamond, club, okay. Heart, spade, diamond, club. That means first 13 card goes to heart, second 13 card goes to spade, for next 13 diamond and last 13 club, okay. This is the complete division of these 13 cards within the 52 cards, okay. Now again 13 cards are having division. How many cards we have here? 13. So we have to go for the division of a 13 card. First as a one as a ace, we consider it as the ace. After 2, 3 up to 10, okay. Then jack, king and queen, okay. This is a J, K and Q, okay. Jack, king and queen. This is the complete division of our 52 cards. Always remember that question based on the deck, set of a deck you will get definitely in your question paper, okay. There are about near about 4 to 5 questions You will get it into your question paper, okay? And based on the probability chapter, you will get the near about 14 to 15 at least 14 to 15 question you will get it based on the probability, okay, on your exam. So be prepared with these all the topics, okay? First of all, you have to go for the dice, deck and coin. These three different outcomes are very much important here in our probability, okay? Yes, I'm expecting that you all have understood everything that I explained here in my general part, okay? Let's move for the next part, which I'm going to explain some of the example. All are not possible, but I will explain some examples to you all here, okay? Yes. Okay, just a minute. Hold on a second, just let me zoom it out. Yes. Yes, we do have here, because it is not just looking good, okay? Let me just arrange it on the way. Yes, okay. I will explain one example here. Okay, we have a pair coin toss repeatedly. A tail appears on the first 4 tosses. Then the probability of a head appearing on the 5th equal tosses. Okay. Now let's think about the question what we have given in our question. Okay. Try to understand the question first. You will get the definite answer easily at the end. Okay. Yes. Here in our question, a pair coin toss repeatedly. Okay. So we have one coin which toss repeatedly. Okay. Single coin it is there which toss repeatedly. If tail appear on the first 4 tosses, okay? If tail appear on the first 4 tosses, then the probability head appearing on the 5th equal toss, okay? Probability of head appearing to the 5th equal toss, okay? Let me find. Okay, so what we have here? A coin toss. Let me just take this one. A coin toss. Okay, a coin toss. Okay, if a single coin can be tossed, then we get the whether it is head or tail. Only one of the option it is possible. Okay, yes, that means if you toss n number of a coin, you will get the equal number of head and equal number of tail. Okay, equal number of head and equal number of tail. What we are doing? We are tossing only single coin at a time. Okay, single coin at a time. Then we have possibility whether it is a head and whether it is a tail. Okay, only 2 possible options here, which is a head or which is a tail. Okay, now see that if you toss n times a single coin, you will get the equal number of likely outcomes. Okay, so number of heads here number of heads which is equal to number of, here we get the number of heads and number of tails both are equal. Okay, number of heads and number of tails both are equal, and we know that when we add n number of a probability, we get the value 1. Okay, so probability of A plus probability of B, which gives us the value 1. Okay, if the number of heads and number of tails both are equal in the case, then probability of A, which gives us 1 half, and probability which gives us 1 half, then and then this condition hold here. Okay, then and only then this condition hold. So we get the probability of appearing on a 5th toss, which is equal to 1 half. Okay, this one is our required answer here. Okay, I'm expecting that you all have understood this part, that to get probability of head and a tail in the separate likely outcomes. Okay, so probability of head which is equal to probability of a tail, it remains same here. Okay, so I'm expecting that you all have understood it here. Okay, let's move for the next part of the questions. Okay, so already we have explained probability of a coming likely outcomes based on the tossing of a coin, tossing of a dice, and tossing of a deck. Okay, that's it.